that this is the last episode of our virtual camp.
Me neither, Taylor. We've got to make sure we go out with a bang, not a shock.
Owie.
You can say that again. Wait. Shock. We're here in the Centennial Lab at the Michigan Science Center. Izzy, are we doing something with electricity today?
Yes, we are.
Wait, but is that safe? We're not supposed to play with electricity.
Well, Taylor, it's all in the name of science.
Oh, I don't know, Izzy.
Don't worry, Taylor. I've got an expert who knows all about these kinds of things.
Oh, well, why didn't you say so?
Let's go. Let's go. Hi, Anna.
Hi, guys.
It's good to see you again.
Welcome back.
Thank you.
Can you tell our friends out there what you do here at the Michigan Science Center?
Sure. Well, I'm the Traveling Science and Distance Learning Coordinator, meaning my job is to take experiments like this one and bring them to kids all over Michigan and even farther using our distance learning program.
Wow. So Izzy tells me that you're going to show us a safe way to use electricity.
It's very true. You should always be careful when you're working with electricity because...
Safety first!
Exactly. But I do have a pretty fun and safe experiment for us to work with electrical circuits.
Okay, you were right. I'm excited.
So for this one, we're going to need Well, first we're going to make our conductive dough. And so this one takes a few special ingredients. The main ingredients to make any kind of clay or dough is going to be flour and water. So Taylor, if you want to add 1 cup of flour.
1 cup of flour.
1 cup of
Here
flour.
we go.
And 1 cup of water.
Oh, right here. Oh, I don't want to spill
Be
it.
very careful.
Am I doing good, Izzy?
Doing great.
Thanks. Okay.
Now we'll also need lemon juice for our conductive dough, as well as salt.
Okay.
Now you can begin to stir that mixture. Now we get to pick what color we'd like our conductive dough to be. I'm thinking orange.
I'm in.
Orange sounds great.
So we're going to add about 20 drops of orange food coloring.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20!
All right, go ahead and stir that in.
It looks like scrambled eggs now.
Yeah, so once that mixture is completely mixed, then we're gonna move it over to the stove. Now remember, you should always have an adult with you when you're working with the stove at home.
Because
Safety first!
So the very last thing I'm going to add while you're stirring, Taylor, is some vegetable oil. How does it look, Taylor?
it's almost mixed.
Almost mixed.
There's still chunks.
That's okay. We
Oh,
can
okay.
move it over to the stove. Keep the spoon in there because we're gonna
Keep
have to
the spoon.
continue to stir while this is on.
Oh, okay.
And so you'll just stir this until it turns into one big dough ball in the center of the pot.
Dough ball.
dough looks great.
It does.
Well, how does it work?
So the two different types of dough we make have different jobs in our circuit. The orange dough is our conductive dough. This one has salt and lemon juice in it, which allows electricity to flow through the dough. But the blue dough is your insulator. Now, instead of using salt, we use sugar to replace that ingredient, which is going to act as an insulator, meaning it stops the flow of electricity. So what we can do is we can rotate the layers of conductive versus insulating dough to make a fun creature. And then we can plug it into an LED light bulb. So what you'll notice is that the end of our LED light bulbs are different lengths. The long end of the LED bulb is the positive end, and that should go near the top of your battery. The short end is the negative end of your light bulb, and that should go near the negative end of your battery pack. So when we insert this in here, one end goes in each side across the insulator. Okay, so if our dough creature is all done, what we're going to do is we're going to take our battery pack with 2 electrodes and plug one side into this side of the dough with our light bulbs and the other to the other end of our electrodes. Now go ahead, Taylor, and turn it on.
Okay, ready?
Ready.
1, 2, 3.
Whoa! Like this.
You can buy them at any hardware store. You can also use alligator clips instead of these wires. So that dough is actually acting as wires itself. So the electricity is flowing through the dough, through the wires from the batteries, which is causing the light bulbs to light up. But Taylor, what would happen if you took out one of the electrodes?
Oh, I don't know. I'm going to try. Okay, ready? Here we go.
I know, I think I know.
The light went out.
That's because we've opened the circuit. When circuits are open, the electricity has nowhere to flow. You've stopped it. But if we take the electrode and put it back in,
The light's back up.
yeah, we've closed our circuit and the electricity is able to flow again.
It all makes so much sense now. I'm shocked. No, not like that. I'm just so surprised that it was so fun and easy.
Well, I'm glad I was able to help you understand it better.
Thanks, Anna.
Thanks, Anna.
Wow, Izzy, I can't believe how much fun I had learning about circuits.
Me either. And I'm also shocked that this is our last virtual camp episode for this summer.
Wait, already? But there's so many more fun things to do here at the Michigan Science Center, like Spark Lab or Explainer Station or here in the Centennial Lab.
I know, Taylor. I don't want the fun to end either. Wait a second. It doesn't have to. We can revisit every experiment whenever we want.
Oh, that's right. So I can totally go make another rain stick or another rocket.
And I can totally make another ice ball. Those were the coolest.
But you know what I'm going to do first?
What's that?
I'm going to go make some more squishy circuits.
Oh, and remember, you can try this experiment and all other 5 experiments anytime. Just join the virtual camp from Metro Parent and the Michigan Science Center for all the details.
See you next time.